Emerging frontiers in multi-agent systems and artificial intelligence are explored through 12 papers published on May 3, 2025. This synthesis highlights cutting-edge research in multi-agent systems, focusing on key themes including explainable AI, quantum classical hybrids, and weak supervision. Selected breakthroughs from the arXiv preprint server CS.MA category are examined along with methodological innovations and future directions in the field. Multi-agent systems, categorized as CS.MA in the arXiv preprint server, represent a field dedicated to modeling autonomous decision-making in complex environments. These systems consist of independent agents coordinating behaviors with critical applications in air traffic control and autonomous vehicles. Two key papers are analyzed, one addressing weather management and another examining public space behaviors. This interdisciplinary domain combines artificial intelligence, robotics, and social dynamics. The first research theme focuses on explainability in artificial intelligence, making AI decisions transparent and auditable. Cristani and colleagues demonstrate legal coding through Deontic Defeasible Logic, introducing a depth metric that quantifies legal reference chains with an R-squared value of 0.89. Their Houdini engine validates rules against edge cases, enabling regulators to audit AI-driven legal decisions with unprecedented transparency. Quantum classical hybrids form the second research theme, bridging quantum computing with traditional artificial intelligence. Andrés and collaborators present quantum spiking neural networks for fraud detection, achieving a 23% accuracy improvement over classical models. Their hippocampal-inspired quantum architectures show promise, though current implementations remain limited by hardware constraints. Weak supervision emerges as the third research theme, addressing learning with limited labeled data. Wu and team develop a method for audio forgery localization, using only utterance-level labels. Their approach employs contrastive learning to align audio-language features, achieving state-of-the-art results on 3 benchmarks without frame-level labels. A noted risk involves potential error propagation during pseudo-label refinement. Generative AI for social impact constitutes the fourth research theme, examining how to amplify influence while preserving intent. Zhao and co-authors optimize large language models for social media influence, carefully balancing amplification with user intent preservation. Ethical considerations highlight potential misuse, pointing to future needs for better safeguards and validation mechanisms. Key findings across the papers demonstrate breakthrough results with real-world impact. Cristani's legal AI shows linear prediction of coding time, while Andrés' quantum approach delivers a 23% improvement in fraud detection. Wu's audio forensics achieves state-of-the-art performance without frame labels, and Choi's air traffic research reduces weather delays by 17%. Methodological innovations driving progress include Cristani's Deontic Defeasible Logic for encoding legal norms as computable rules. Wu's progressive co-learning combines contrastive learning with pseudo-label refinement, while Wang employs optimal transport using Wasserstein distance for animation. Khan's convex set modeling demonstrates a 41% reduction in unnatural behaviors. The seminal paper by Cristani and colleagues titled Explainability by Design in Legal AI translates legal texts into Deontic Defeasible Logic rules. Their depth metric correlates with coding time, showing an R-squared value of 0.89. The Houdini engine validates rules against edge cases, enabling transparent auditing of AI-driven legal decisions with significant regulatory implications. Khan's influential work on naturalistic behavior modeling for autonomous agents represents human behaviors as convex sets. Validated using the IND dataset of real-world driving behaviors, this approach achieves a 41% reduction in unnatural behaviors. A noted limitation involves sensitivity to set initialization parameters during model configuration. Choi's research on pathfinders and air traffic control formalizes scout aircraft operations as a Markov decision process. The study identifies collective rejection scenarios where no aircraft accept pathfinder roles, proposing utility-based incentives for altruism as a solution. Implemented simulations demonstrate a 17% reduction in weather-induced delays. Future directions highlight several challenges and opportunities. Scalability remains constrained by quantum hardware limitations, while data efficiency requires better error bounds for weakly supervised methods. Ethical considerations demand safeguards against potential misuse of influence. Amplification technologies, with interdisciplinary validation emerging as a critical need across domains. 3 key takeaways synthesize this multi-agent systems research. First, Cristani's explainable AI enables auditable legal decisions. Second, Andrés's quantum hybrids demonstrate measurable advantages in fraud detection. Third, Wu's weak supervision achieves state-of-the-art performance with reduced data requirements. A cross-cutting need emerges for robust ethical frameworks governing deployment of these technologies. This research synthesis was powered by artificial intelligence, with content generated by a GPT model and audio narration synthesized using DeepGram. Visual concepts were designed via stable diffusion, while all technical content underwent human expert review. The methodology involved thematic analysis of 12 arXiv preprint server papers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.